Dear students, good evening. I am Ramdas. I welcome you to my channel Maths from Basics for you. So this is my class number 36. In the previous class I have taught for 7th standard 2 videos. So now I am back to my diploma students, PUC students as well as my engineering students. So I have to give prominence to 7th, 8th, 9th, 10th PUC students also, so that I would like to groom them and prepare them for engineering or higher studies. So that's the reason I tried 2 videos. I'll see how is the output, how is the response from that end. In the event if they start liking my videos, I'll start doing parallelly, otherwise I'll concentrate much on PUC, diploma as well as engineering students. Let us see for 8th and 9th also I try to post some videos, do some proper classes for them. Let me see how I get the response. So dear students, in the previous class we have learnt how to find the antiderivative of log functions, exponentials as well as trigonometric antiderivative of trigonometric functions. Today we are going to learn how to find the antiderivative of arithmetic functions by the method using partial fractions. So dear students, this also more or less we are going to work it on the same grounds but slightly different. It needs a little bit of preparation which I am going to teach you. So dear students, first of all let's know how to find antiderivative of arithmetic functions. Let us take an example and I'll tell you what it is. But before I get into that, I remind you of my funda. Learn maths right from basics. I am here to teach you maths right from basics. So dear students, let's start. So dear students, let us take an example. That is, let y equals 6x by x square minus 4 into x minus 1. So dear student, first of all what you have to identify here is first ascertain whether the given fraction is a proper fraction or improper fraction. Now some of you would have forgotten what a proper fraction is because you have reached some higher level. So probability are there, you would have forgotten. So that is, if the degree of denominator is higher than the degree of numerator, then such a fraction is called a proper fraction. For example, if you take numerically, if you have 3 by 5, so here the value of 5 is, that is the denominator is greater than the value of numerator. So this is a proper fraction. On the contrary, if you reverse this and say this is not a proper fraction but an improper fraction because the degree of denominator is lesser than the degree of numerator. So this is proper fraction, this is improper fraction. Likewise, here too it is a proper fraction because look at the degree in the denominator, that is x square minus 4 into x minus 1. So if you multiply all this, it becomes x cube. So in the numerator you have x, 6x. So here the degree, the value of numerator is less than the value of denominator. On the other hand, the value of denominator is much higher than the value of numerator. As such, this is a proper fraction. So I give some small note on 4 points. Try to remember that points, that is important to you. Let's see what those points are. Now, first point, note. So I have told you about proper fractions and improper fractions. That is, if the degree of denominator is higher than the degree of numerator, it is a proper fraction or it is not. If the numerator's degree is higher than that of numerator, it is an improper fraction. So I have explained to you. So what I'll do, first I'll try to factorize this. So we have, let us say, that is x square minus 4 can be written as what? Can I write like this? A square minus 2 square, isn't it? So this can be written as x square minus 4 square can be written as x square minus 2 square. And what is this? This is of the form what? A square minus b square, right? this is nothing but a square minus b square, this, isn't it? So which is equals to what? A plus b into a minus b, isn't it? So I can write this as what? That is, this can be written as what? That is 6x by x minus 2 into x plus 2 into x minus 1, right? So what I'll do, I'll see that this is equals to what? I'll rub this. So I'll take this in center. 6x by, I have factorized this and brought it a simplified form. So what I do, let this be equals to, I'll introduce a constant x minus 2 plus b by x plus 2 minus c by x minus 1. So what I have done, for this 6x on the left hand side, I have introduced a constant a by x minus 2, b by x plus 2, plus a by x minus 2 plus b by x plus 2 plus c by x minus 1. So what I do the next, so this is a proper function. So this is a proper fraction since the degree of denominator is higher than the numerator, isn't it? No. Whenever you are given some problem on proper fractions, we have certain important parameters which you need to know before you proceed. First thing is what? I'll write some note which is important. Note number 1, we have to ensure the given fraction that is f of x by g of x is a proper fraction, and then resolve it into partial So what you have to do? First we have to ensure that whether a given fraction is a proper fraction of type f of x by g of x is a proper function or not, and then resolve it into a partial fraction. Next, number 2, that is find, I write then find, second point, then find the nth derivative term by term. So later on we have to find the nth derivative of it term by term. Third point, if the given fraction is an improper fraction. So if the given in the event if the given fraction is not a proper fraction and it is if it is an improper fraction, then we have to divide and rewrite the fraction which involves a proper fraction. So what is point number 3? If the given fraction is an improper fraction, instead of proper fraction we get an improper fraction, then we have to divide and rewrite a fraction which involves a proper fraction. So in easiest way, so what you have to do, if the degree of numerator is higher than the degree of denominator, then we have to convert the numerator, then we have to divide the numerator by denominator. I will show you how to go about it when I do a problems on improper fractions. So, and last point I will write here, I rub this. And last point I will write here only, fourth one. Proceed to find the nth derivative as before. So what you have to do? First, ensure the given fraction is proper fraction. Then next, then find the nth derivative term by term. Next, if the given fraction is an improper fraction, we have to divide and rewrite a fraction which involves a proper fraction. And last, proceed to find the nth derivative as before. What it is? We have found the nth derivative of some functions earlier. So on the same basis, we have to find the nth derivative of given function. So let's start now. So this is more than enough for you to understand. These are steps you need to know before finding the nth derivative. So let's students, I'll rub this. So I have first taken the given problem. I call this as let y equals to, that is y equals to six x by, I take this x minus 2 x plus 2 into x minus 1 equals to, I will take this a by a by x minus 2 plus b by x plus 2 plus c by x minus 1. X minus 1. So what I will do now, what we are supposed to do now is, I will multiply both sides. I want to get rid of this on the denominator. So what I will do, I will multiply both sides by x minus 2 into x plus 2 into x minus 1. So by multiplying both sides by x minus 2 x plus 2 into x minus 1. So that means to say that both sides in the sense you multiply LHS by x minus 2 into x plus 2 into x minus 1, and right hand side also you have to multiply with the same values. Disturbance. So that is what happens here. The right hand side, left hand side, y equals to 6x by x minus 2 into x plus 2 into x minus 1. So I am multiplying both sides, that is x minus 2 into x plus 2 into x minus 1 equals to a by x minus 2 plus b by x plus 2 plus c by x minus 1 into, I will multiply this, x minus 2 x plus 2 into x minus 1, right? So what happens here? This and this cancels, alright? Here what happens? So I'll rub this. So I'll rub this. So what happens? On the left hand side, that is y equals to, you will have 6x equals to, so a into, so x minus 2 cancels, so you are left with what? A into x plus 2 x minus 1 cancels into x minus 1 plus b into x plus 2 cancels, you are left with x minus 2 into x minus 1 plus c into, so x minus 1 cancels, you are left with x minus 2 into x plus 2. I call this equation as equation 1. Got it? So once again, so I have multiplied both sides by x minus 2 into x plus 2 into x minus 1. So what happens on the denominator, and this gets cancelled, you are left with 6x. Done. So here on the right hand side, a, so this x, if I multiply this and this gets cancelled, you are left with a into x plus 2 into x minus 1. B, x plus 2 cancelled, you are left with x minus 2 into x minus 1, x minus 2 into x minus 1 plus C into x minus 1 gets cancelled, you are left with x minus 2 plus x plus 2. Understood? Okay, dear students, I rub this. So dear students, now we have to find the values of A, B and C. In order to find the values of A, B and C, we shall set some values for x by setting distinct factors in the denominator to 0. Note, in order to find A, B and C, we shall prefer to select some values of x setting distinct factors in the denominator to 0. What you have to do? I rub this. That is, x minus 2 equals to 0, x plus 2 equals to 0 and x minus 1 equals to 0. From this we will get the values of 3 different values for x. First, that is x minus 2 equals to 0 and x equals to 2, right? So what happens here? X will go to the right hand side and becomes plus 2, 1. So I'll take this x plus 2, that is x plus 2 equals to 0 and x equals to minus 2. So what happens here? I am showing this x minus 2 equals to 0 or x equals to, the moment x goes to the right hand side it becomes plus. So in this case it becomes minus, and x minus 1 equals to 0 or x equals to 1, right? That is x equals to 2, x equals to minus 2 and x equals to 1. These are 3 values we will get for x. So what we will do is, we will substitute the value of x equals to 2 in equation 1 to begin with, and later on we will put the value of x equals to minus 2 in equation 1, and later on we will put x equals to 1 in the equation 1. Thereby we will get all the values of A, B and C. We will try this. So what happens here? Now from equation 1, that is what? 6x equals to what? A into x plus 2 into x minus 1 plus b into x minus 2 into x minus 1 plus c into x minus 2 into x plus 2. This is our equation 1. That is our equation 1. I'll rub this. So I'll rub this. I'll rub this also. This is not required now. So that is x equals to 2, x equals to minus 2 and x equals to 1. I'll rub this also. So to begin with, in equation I'll put x equals to 2. So put x equals to 2 in equation 1. I'll write before that, I'll write like this: to find A, B and C. First put x equals to 2 in equation 1. What happens? That is, equation 1 is, on the left hand side we have 6 into 2 x since x equals, that is, since x equals to 2. I have already written here, no need. So x equals to 2 on the left hand side. So this equals to what? A into x equals to 2 plus 2 into 2 minus 1 plus b into 2 minus 2 into 2 minus 1 plus c 2 minus 2 into x plus 2. What happens here? 2 minus 2 is 0, that is, this is 0. So 0, if you multiply this, the entire thing becomes 0, and here also 2 minus 2 is 0. So if you multiply everything, this becomes 0. Done. So I have the equation, I have this equation now. So here I write here x equals to, x equals minus 2 and x equals to 1. I write this. What happens here? 2 into 6 is 12 equals to a into 2 plus 2 is 4 into 2 minus 1 is 1 plus 0 plus 0, because this entire thing becomes 0. So this is what? This is 12 equals to a into 4, that is 4a, that is a into 4. Therefore a equals 12 by 4 equals to 3. So we have got a value of a, this is nothing but 3, value of a. Okay, please make a note of this. So now I'll rub this, you have copied. Okay. Second, put x equals minus 2 in equation 1. So second, put x equals minus 2 in equation 1. Okay, I'll write this. I'll rub this. Then x equals to 3. Now, put x equals minus 2 in equation 1. So, this will be on the left hand side 6, this will be 6 into minus 2 equals to a into minus 2 plus 2 into minus 2 minus 1 plus b into minus 2 minus 2, and this is minus 2 minus 1 minus 2, this is minus 2 minus 1 plus c into minus 2 into minus 2 plus 2. So what happens is, students, we have minus 2 plus 2 is 0. So the entire term, a term becomes 0, since minus 2 plus 2 is 0, and here minus 2 plus 2, again this also becomes 0. So what happens to the left hand side? We will have that is equals to minus 12 equals to 0. So this is minus 2 minus 2 is, this becomes minus 4 into minus 3. So minus into minus plus 3, sorry, minus into minus plus into 4 into 3 is 12, plus, you want me to write this? Okay, b into minus 4 into minus 3, and this becomes 0. So what happens to this? This is minus 12 equals to minus into minus plus, so plus 12 into b. Therefore b equals to minus 12 by plus 12 equals to minus 1. Therefore b equals minus 1. So b is nothing but minus 1. I'll rub this, make a note. Lastly, put x equals to 1, because x equals, value of x is 1 in equation 1. So what happens to this? That is 6 into 1 equals to a into 1 plus 2 into 1 minus 1 plus b into 1 minus 2, and this is 1 minus 1 plus c into 1 minus 2 into 1 plus 2. So 1 minus 1 is 0, this is 0, 1 minus 1, so the entire portion becomes 0. Once you multiply everything, this becomes 0. Here also 1 minus 1 is 0, so the entire thing becomes 0. So here, what happens here? That is 6 into 1 is 6 equals to 0 plus 0. So here c into minus 1 into minus, that is plus 1 plus 2 is 3. So this is equals to minus 3. So minus 3, which is nothing but 6 equals minus 3 c, minus 3c, isn't it? Therefore c equals 6 by minus 3, nothing but minus 2. Therefore c equals to minus 2. So what happens to c? C becomes minus 2. So now we have got the values of A, B and C by this. So I'll show you next step. So I'll rub all this. I hope you have copied this. I'll rub this now. This is of no use. Now y equals to, what happens here? A by x minus 2 plus b by x plus 2 plus c by x minus 1. So I got the values of this. So this is nothing but, what is the value of A? 3 by x minus 2. So minus 1. So minus 1 by x plus 2, and c is minus 2. So minus 2 by x minus 1. So I'll use the bracket here. Okay, next I will write. That is y equals 3 by x minus 2 minus minus 1 by x plus 2 minus 2 by x minus 1. So after coming to this, now we are able to differentiate this to nth time, because it is of the form what? This is of the form what? So I call this as equation 2. Here equation 2 is of the form dn to the power of d to the power of n, that is nth derivative of given function, that is 1 by ax plus b equals to what? Minus 1 to the power of n into a to the power of n into n factorial divided by ax plus b to the power of n plus 1. So this equation is the form 1 by x plus b is of that form, and the solution is minus 1 to the power of I'll write this minus 1 properly. Minus 1 to the power of n, a to the power of n, and n factorial divided by, this is of the type ax plus b to the power of n plus 1. So we'll apply this to this problem now. I'll rub this. So dear students, now we are going to find the nth derivative for this arithmetic function. So we know dn of 1 by ax plus b equals to, the solution is minus 1 to the power of n, a to the power of n, n factorial. So here very important fact is this, very important factor is this, because most of you assign this 3 to the power of n. Don't do that, don't commit that mistake. So that means what? I'll show you. This is nothing but, that is 3 into coefficient of x is what? 1. So this will be minus 1. This formula is minus 1 to, as it is always, right, minus 1. Now the coefficient of x is 1, that is 1 to the power of n into n factorial divided by x minus 2. X minus 2 to the power of n plus 1. Minus, we have 1 minus 1 into minus 1 into minus 1 to the power of n into 1 to the power of n into n factorial divided by, rub this, no need, divided by x plus 2 n plus 1 minus this 2, and take it outside, 2 into minus 1 to the power of n into 1 to the power of n into n factorial. There is no bracket for this, no need to put a bracket straight away. So into n factorial divided by x minus 1 to the power of n plus 1. So close the bracket now. So dear students, here I have actually completed the problem, but if you want, you can add one more step here. So that looks nice, we can definitely add, because I want to teach you steps how to simplify things. So what I do here, I remove this 3, 4, therefore I remove this also. Now just note this, among all this, what are common here? Minus 1 to the power of n is common, n factor is common, 1 to the power of n is common, right? I'll take all those things outside. So, and I write therefore yn equals to, I'll open a bracket, square bracket, I'll now, so yn equals to, I'll take minus 1 into minus 1 to the power of n into n factorial is common, so that is common between all the three values. So I'll take, this is minus 1 to the power of n into n factorial. 1 to the power of n is nothing but 1, so need not write it, so you can just ignore it. I have taken these things common. So what is left here? You are left with what? 3 by x minus 2 to the power of n plus 1. Done. You have minus. So we have minus, that puts at minus. We have 1 here, 1 by x plus 2 to the power of n plus 1. Again we have minus, alright, minus 2 by x minus 1. x minus 1 to the power of n plus 1, and I'll close this bracket. So therefore this is a final answer. So dear students, if you can definitely recollect this, and if you practice this, definitely you can do this problem. So only thing I have taken minus 1 to the power of n common, n factorial, 1 to the power of n is 1 only, so need not write that. So if you can do this much, you are going to get your full marks. So very simple problem. Let's go for the next problem. If you do 2 or 3 problems on this topic, definitely you will be well versed. So we'll go for the next problem. So dear students, we have another next problem, that is y equals to x by 1 plus 3x plus 2x squared. So here first and foremost thing is you have to find out whether given fraction is a proper or improper fraction, and we know the degree of denominator is higher than the degree of numerator. As such, it is a proper fraction. So to get a degree of this, the degree of this is 1 and the degree of this is 2. So this is a proper fraction. Now we'll try to do this problem like the previous one. It's similar to that. Only thing, you have to factorize this, you have to learn the quadratic equation. We'll rearrange this. So what I do, I'll rearrange this. Okay, write like this, that is x by 2x square plus 3x plus 1. I rearrange this. Okay. Now we have to factorize this. What do we do? This factorization, let me not waste my time here. So if you want, I am going to do this factorization for 9th and 10th and even for 8th standard. So there, if you want, I will tell you the video there. In the unit, if you want, I definitely, there also I take separate class for factorization. So I will tell you the method how to do it. So what happens, I have 2x square plus 3x plus 1. So what I do, I will introduce this. So I can write this as 2x square plus 2x plus x plus, you can write like this. So if you add up, you get 3x, and if you multiply this, the difference is 1. So now what I do, that is 2x square, 2x plus x. So what I do, I try to make this common. So what is common here? 2x is common, this becomes x plus 1. I take plus 1 is common, there will be x plus 1. In the event you get x plus 1 and x plus 1 in the bracket, means to say that whatever you have done is correct. So this will be what? This is nothing but x plus 1 into 2x plus 1. If you multiply this, you will get back this. So this is nothing but this. So what I do, let y equals xy, I write that x plus 1 into 2x plus 1 equals to a by, I write this x plus 1. I will explain what it is. B by 2x plus 1. So what I have done on the left hand side, I have assumed a plus 1 value I have taken here plus b by. Now we are supposed to find the values of a and b. So it's very easy. What I will do, I call this as equation 1. So in order to find the value of a and b, I have taken denominator of a and denominator of b and equate them to 0. So that we get two different values for x. So we will proceed. That is, first case, case 1, that is, put x plus 1 equals to 0. I'm talking about this. What happens to this? Therefore, x equals to minus 1. Case 2. Case 2. Put 2x plus 1 equals to 0. I am equating this to the denominator to 0 in order to find the values of x. So this will help me to find the values of a and b. So this will be what? This will be x. So this is 2x plus 1 equals to 0 or 2x equals to minus 1. If this 1 will go to the right hand side, it will be minus 1. Therefore x equals to minus 1 by 2. That is, x equals to minus half. Done. So we have got write it here separately. X equals to minus 1 and x equals to minus half. I wrote this. Now what I do, I will multiply this equation number, equation 1, with the denominators of the left hand side. So if I multiply, what happens here? That is nothing but, if I multiply this, anyway for this problem I will show you, this will be x plus 1 into 2x plus 1 into, this will be what? X plus 1 into 2x plus 1. So on right, both the sides I multiply by this value, whatever you have in denominator, I will multiply, so I will get rid of this denominator. So this is equals to what? This equals to a into, so here also I will multiply by x plus 1 into 2x plus 1. So this x plus 1, this x plus 1 cancels. So I left with what? 2x plus 1 plus b into this 2x plus 1. I will remove this. So this 2x plus 1, this 2x plus 1 cancels, and we left with x plus 1. Done. So what happens here? This cancels, this cancels, this cancels, this cancels. So what we have? This is nothing but x equals to a into 2x plus 1 plus b into x plus 1. I call this as equation 2. Equation 2. Now what I do, we have already found out the values of x equals to minus 1 and x equals to minus half. So first case I put x equals to minus 1, equation 2. Case 1. Case 1. Put x equals to minus 1 in equation 1. What happens here? So this is that is minus 1 equals to minus 1 equals to a into 2 into minus 1 plus 1 plus b into minus 1 plus 1. What happens here? Minus 1 plus 1 becomes 0. So the entire thing becomes 0 on the left hand side, on the right hand side. So what happens to this? So shall I have this? Yes sir, go ahead. that is equals to minus 1 equals to 2 into minus 1 minus 2 plus 1, so minus 1. So this will be a into minus 1 plus 0. So both sides we have minus, so I multiply both sides by minus or divide throughout by minus sign. What happens here? Or 1 equals to a1, therefore a equals to 1, correct? So this 1 will go below this, finally we get a equals to 1. So we will note down the value of this, a equals to 1. I wrote this? Yes sir, go ahead. So next, put x equals to minus of, so case 2. That is case 2. Put x equals to minus of in equation 1. What happens here? X will be, that is minus of, x is minus of on the left hand side equals to a, 2 into minus of plus 1 plus b into minus of plus 1, correct? So here 2 1s are, so 1 into minus 1 is minus 1, minus 1 plus 1 is 0, so this term, entire term becomes 0, so 0 into e is 0. Now here, so this is equals to what? This is equals to minus half on the left hand side, minus half equals to a is 0, I write at 0, so minus half plus 1, so from 1 plus 1 if you remove minus half, it will be plus half, so this will be plus half, done. So this is equals to what? Into b, into b. So what happens to this? This is nothing but minus of equals to b into half. So what I do? I cross multiply. Okay. So cross multiply means I put like this. This is cross multiply. So this becomes what? This becomes minus 2 by plus 2. So this is equals to minus 1. Therefore b equals to minus 1 and b equals to minus 1. So we have got the values of a and b. You understand this? So I am teaching you this, the simplest method. So if you can compare this with other YouTubers, you will find the way I am teaching you, you feel very comfortable and relaxed. So you will not have doubt, you will not carry any doubt to your house. So everything will be dealt here without any hesitation. So pay your attention, focus your mind here and learn. So we have got all the values. So from this also, now what I do? I substitute these values. I wrote this? Yes sir. Please rub it sir and finish the problem sir. Okay, na? Okay, I got this also. This value is over. This also is over. I remove this. So now, straight I will take this. That is y equals to what? A by x plus 1 plus b by 2x plus 1. Now this is nothing but what? Y equals to, what is the value of A? A is minus 1 by x plus 1. So you have minus, B is also minus, then no, A is plus 1, A is plus 1 minus 1 by 2x plus 1. I'll follow the same format. What I do, A by this value, I write this plus itself here, and I take, what is B? Minus 1. Let me not get, I don't want you to get confused. So A is one by x plus 1. Value of A is 1 by x plus 1 plus B is minus 1 into 2x plus 1. Done. So this is our y. So this is nothing but what? This is nothing but y equals to one by x plus 1 plus into minus 1 by 2x plus 1. So you followed. Now we have reached a stage where we can find the nth derivative of this. This is the form what? So I'll write, I call this as equation 3. So no, equation 3. Equation 3 is of the form d to the power of n, that is, we are finding the antiderivative of the given, that is nothing but 1 by ax plus b, and the solution is what? Minus 1 to the power of n into a to the power of n into a to the power of n into n factorial divided by ax plus b to the power of n plus 1. This is the formula for this type. So now this is of this type only. So what I do? I have this. Now I am going to differentiate this nth time. Y will be what? Nothing but dn of 1 by x plus 1 minus 1 by 2x plus 1. Right? So I can rub this now. Therefore yn will be what? So here minus 1 to the power of n. A to the power of n is what? It's catchword of this value. What is the coefficient of x? Is 1. So this will be 1 to the power of n. That is, a to the power of n is nothing but 1 to the power of n into n factorial divided by x plus 1 whole to the power of n plus 1 minus here, that is minus 1 to the power of n, and here the coefficient of x is 2 and this become 2 to the power of n. Remember this, don't write whatever value, even if you had here 4, don't write 4 to the power of n, you will be wrong. Whatever you have, that value you have to take. Coefficient of x, whatever you get, that should be the value here, into n factorial divided by 2x plus 1 whole to the power of n plus 1. So, dear students, if you want you can stop at this, but still if you want you can do one more step, that is among this you can take out a common, that is minus 1 to the power of n is common in both the cases and n factorial is common, you can take it out. So, I wrote this. So, I have output therefore for this, here I write, which is equals to yn will be what? I will take minus 1 outside to the power of n into n factorial, I take it outside. So, 1 to the power of n is nothing but 1 itself. So, if you want you can write, that is 1 by x plus 1 to the power of n plus 1 minus 2 to the power of n, 2 to the power of n by 2x plus 1 to the power of n plus 1 and n plus 1, sorry, n plus 1. So, this is the required answer. So, therefore, y will be this. In the event if we had 2 to the power of n, that also would have been taken outside, but not a case. So, forget this is the final answer. So, dear students, I hope you have learned this. I'll do one more problem on this. The remaining problems you can refer from other textbooks and you can do. The procedure, method, everything is same. Let us not waste more on time on this because simple problems you can easily follow this procedure and do it. So once you do it, first what you have to do, find whether it is a proper fraction or not. In a nutshell I am explaining you, it is a proper fraction. Then equate that to a by whatever it is and the denominator equated to 0, find the values of x. If you have 3 terms, find out 3 terms also. You will have 3 x's. Values for 3 values for x. If it's 2, you will have 2 values for x. Substitute that in equation to whatever you have done it. Find the values of a and b and substitute like this, and finally using the formula you apply. This is how to find integrity of proper fractions. Now let me take after this one more problem and let's take improper fraction to it. So let's put this off here. So dear students, we have a problem y equals to 1 by 1 minus x square plus x cube. So we have to find the common out of this, simplify this. So find the factors in this and try to substitute like what you did in the previous problem. What I do, I take this. This is equals to what? So I take 1 minus x minus x square plus x cube. So I take like this. What is common here? 1 is common, that is 1 minus x. So I take minus x square common. So this becomes what? 1 minus x. So see, if you multiply, you get the same thing here, minus x square minus into minus plus, so x cube. So what is common here? This is equals to 1 minus x into 1 minus x square. We have 1 minus x into 1 minus x square. Still, it can be solved further. What I do is, I write like this. This is nothing but 1 minus x. This is the form what? 1 square minus x square. Can I write like this? We have, that is 1 square minus x square. This is nothing but a square minus b square, isn't it? What it is? This is nothing but x minus a into a plus b into a minus b, right? So what I do, this can written as what? So this is nothing but 1 minus x. So this is 1 minus x, 1 minus x. For this, I write this. That is nothing but 1 minus x into 1 plus x. Can I write like this? So this is further equals to what? 1 minus x, 1 minus x. Can I write like this? 1 minus x, the whole square into 1 plus x. Because we have 1 minus x, 1 minus x. So that is nothing but 1 minus x, the whole square to 1 plus x. This can be written. So what happens to this? So this will be nothing but 1 by 1 minus x square, 1 minus x the whole square into 1 plus x. I got this. Now let y equals to, I'll write like this, let 1 by 1 minus x the whole square into 1 plus x equals to, dear students, I'll tell you by doing this. So equals to what? A by 1 minus x. See here, some students in the examination, they straight away 1 minus x the whole square. Don't do that. Whenever you get 1 minus x the whole square or 1 minus x cube, you come in order 1 minus x into 1 minus x the whole square into 1 minus x the whole cube, because it's a repeating factor. So whenever you have a repeating factor, try to start with 1 minus x. Okay, then plus b into 1 minus x, 1 minus x the whole square. What it? 1 minus x, 1 minus x square plus c by 1 plus x. This step is very important because most of the students go wrong here. Directly they substitute this and the problem is gone to dogs. So let it not go to dog, let it go to tiger. So what we do is, we have come to this stage. Now what next? What I do, I call this as equation 1. Now what I do, I divide and multiply, I multiply both sides by 1 minus x square into 1 minus x the whole square into 1 plus x on both sides. So what happens here? I write here. Multiply by 1 minus x the whole square into 1 plus x on both sides of the equation 1. What happens here? So once you multiply this, both will get cancelled to the left hand side. So I'll multiply both sides by 1 minus x square, isn't it? So what happens here? So this becomes 1 equals to a into, so you are multiplying this with what? This is only for reference purpose. I am taking this because I don't want you to get confused. This is our equation 1. You are multiplying this with what? 1 minus x, the whole square into 1 plus x, isn't it? So what happens? A into, so you have 1 minus x. So here it will get divided, that is, if you divide this by 1 minus x, this and this cancels. This cancels. So you left with what? 1 minus x into 1 plus x. Correct? Okay. Now b into 1 minus x square, 1 minus x cancel, we left with 1 plus x. 1 plus x plus c into 1 plus x cancel, we left with 1 minus x the whole square. Isn't it? So I call this as equation 2. So I love this also. So equation 2. To begin with, I'll put x equals to 1. So what happens here? X becomes 1. 1 minus 1 0. I'll put that. So put x equals to 1. So 1 equals to, and write like this. Put x equals to 1. So left hand side 1 equals to a into 1 minus 1 into 1 plus 1 plus b into 1 plus 1 plus c into 1 minus 1 the whole square. What happens here? 1 minus 1 is 0. So 0 into this, the entire portion becomes 0. And here 1 minus 1 is again 0. So this also becomes 0. So 1 equals to 0 plus 2b plus 0. Therefore, b equals to what? Half, because so 1 equals to 2b, b equals to 1 by 2. So b equals half. I write here b equals to half here, and tell you how it is. You have 1 equals to 0 plus 2b plus 0, that is 1 equals to 2b, or b equals to 2 goes to numerator denominator, so this becomes half. Therefore, alright, b equals to half. Done. I love this. Next, I'll put in x equals to minus 1 in equation 2. Put x equals to minus 1 in equation 2. So here what happens here? 1 equals to a into minus 1, sorry, 1 minus, that is 1 minus 1 into 1 minus 1, okay, 1 minus 1 plus b into 1 minus 1 plus c into 1 minus of minus 1 the whole square, that is nothing but 1 equals to minus of this is nothing but minus of the 1 plus 1, minus into minus plus 1 into this becomes 0, so entire thing becomes 0, and plus b, this also becomes 0, so b is also 0, plus c, this is 1, minus of minus is 1, 1 plus 1 is 2, 2 to the power of 2 is 4, that is 4. See here, minus into minus plus 1 plus 1 is 2, 2 to the power of 2 is 4, so this is also 0, therefore c equals to 1 by 4 and c equals to 1 by 4. Now lastly, I'll see one thing I want to tell you, important note. Whenever you get this repeating factor, that is 1 minus x to the power, try to use this step whatever I taught you. So don't try to equate this to equals to 0 and do it. It will go wrong because it's not possible to do it. So what you do in the last step to find the value of, you have got b and c, you have to get the value of a. So put x equals to 0. So that is the technique you have to use here. So what I will do, I will rub this, put x equals to 0 in equation 2, 1 equals to a into 1 minus 0 into 1 plus 0 plus b into 1 plus 0 plus c into 1 minus 0 the whole square. Correct? What happens here? 1 equals to, is it possible to see this? Yeah. So this is 1 minus 0 is nothing but 1. This is a into 1. Again this is into 1 plus b into 1 plus c into 1. I love this. Yes, sir. So, on the left hand side you have 1 equals to a1 plus, what is the value of b? b is half, and c is 1 by 4 plus 1 by 4. Now what happens here? this is nothing but on the left hand side 1 equals to half plus quarter is 3/4. A plus 3/4, half plus quarter is 3/4. So therefore A equals to what? A equals, and send this to left side. So 1 minus 3/4, which is nothing but A equals quarter. So 1 minus 3/4 is quarter. So what is A? 1/4. You got all the values A, B, C. Now you use that here. So what happens? Make a note of this. So of this, that is y equals, this is our equation. I write this is from equation 1 we have y equals to a by 1 plus x, a by 1 minus x. What is a? A is 1/4. A is 1/4, or I write like this only, 1/4 into 1 minus x. I write this one here, plus what is b? B is 1/2. 1/2 into 1 minus x, the whole square. Again I'll write this one center, plus c is 1/4. Again this is 1/4, 1 plus x. Correct? Since A equals 1/4, B equals half, and C equals 1/4. I have substituted the values here. Now we have reached a stage where we can find the antiderivative of this given fraction. So what we have to do? These are the standard form. Let us find the antiderivative of this. So one more step. Now yn equals to d to the power of n. That is what you are going to find the antiderivative of this. This will be 1/4 into 1/1 minus half. This will be 1 minus x the whole square, that is 1 by, this is 1/2 into 1 minus x the whole square, plus 1/4 into 1/1 plus x to the power of nothing. So it means to say now we are going to apply antiderivative for this. So now I love this. I love this too. I love this also. I love this also. So now, therefore, y in will be what? So this will be 1 by 4 minus 1 to the power of this n factorial into what is the coefficient of x is nothing but minus 1. So I write into minus 1 to the power of n divided by 1 minus x to the power of n plus 1 plus half 1 by 2. So here minus 1 to the power of n. So 1 minus x whole to the power of 2. Here then here what happens here? Instead of n factorial, right, n plus 1 factorial, n plus 1, since we have whole square, right, n plus 1 into n factorial divided by 1 minus x to the power of n plus 2 plus 1 by 4. So this will be minus 1 to the power of n into n factorial. So the coefficient of x is plus 1. So this becomes 1 to the power of n by 1 plus x to the power of n plus 1. Close the bracket. So dear students, I explain you once again. Y equals to 1 by 4. We have taken this formula 1 minus 1 to the power of n into n factorial minus 1 to the power of n factorial, because the coefficient of x is minus 1 plus half into minus 1 to the power of n, because since we have 1 minus x the whole square, it will be n plus 1 plus factorial, and the coefficient of x is again minus 1. Sorry, here you make this, convert this into, sorry, here. So this is again minus 1, because the coefficient of x is minus 1, not n. So minus 1 to factorial plus 1 by 4 minus 1 as usual n factorial into 1. So what I do, I try to take one more step and write. So here, see, we have minus 1 to factorial. So remember, note, minus 1 into minus 1 power of n equals to minus 1 to the power of 2n. So this becomes what? 1, because 2 minus 2 plus, whenever you have an even to its power, so that minus becomes plus. So, and 1 to the power of n is nothing but 1. So remember this, I have wrote this now. So what I do, here 1 by 4, 1 by 2, 1 by 2, I take 1 by 2 common and I take n factorial common. So yn equals to n factorial by 2 and take common. So we will have 1 by 2, this will be 1 minus x n plus 1. So I write this one in the center so it looks nice. 1 plus, so already I have taken 2, so we will not have this. So here this will be n plus 1 by 1 minus x to the power of n plus 2 plus 1 half you have taken, so left with what? Half into 1 plus x to the power of n plus 1. So I'll write this at the center. So this is the answer. I'll explain once again what I've done. I've taken 1 by 4 outside. Sorry, 1 by 2 outside I've taken because 1 by 2 I've taken. If you multiply 2 into 2 becomes 1 by 4, same thing. So minus 1 I have shown you, minus 1 to minus here also minus 1, minus 1. So minus 1 to the power of n, that becomes minus 1 to the power of 2n. That is nothing but 1. I have taken 1. So nothing is here. This n factor I have taken outside. So nothing is there. We have only 1 in the numerator, isn't it? Plus 1 again minus 1 to the power of n, minus 1 to the power of n again becomes into 1. So these friends, please note here. Minus 1 to the power of n, minus n to the power of n, minus n to the power of n. If you multiply this, becomes minus 1 to the power of 2n is nothing but plus 1. So in this case also minus 1 to the power of n, minus 1 to the power of n. So when you add up this, when you multiply this, that again this becomes 1. But in this case, you have minus 1 to the power of n into 1 to the power of n. So this value should become minus 1 to the power of n. Please make that correction. So in the examination, be careful about this one particular point, because here we have 2 minus 1 to the power of n, that's why it has become plus. But in this case, minus 1 to the power of n into this, if you multiply, you get minus 1 to the power of n. This particular point, please make it note. If you lose this, you lose 1 mark or half a mark. So I don't want you to lose a precious offer 1 mark here. That may drastically bring down your percentage. So be careful with this. If you multiply minus 1 to the power of n into plus 1 to the power of n, it becomes minus n to the power of n. This particular thing, it just went out of my mind, so I made that correction. Okay, dear students, we'll go for next problem, that is improper fractions. Dear students, we have learned problems on proper fractions, that is how to find the antiderivative of arithmetic functions of proper fractions using the method of partial fractions. So we could, if you want, we can do many number of problems, another 5 to 10 problems, but it is waste of time because all the problems are more or less similar to each other. Only thing what you need to know is you should know the procedure and method, how to solve it and how to apply the formulae. So once you know that, any number of problems you can do it on your own. So I have given you the abstract of this problem. So now we'll think about solving problems on improper fractions. So I had told you proper fractions are where the value of denominator is higher than the value of numerator. So in improper fractions, the value of denominator is equal to or less than the value of numerator. Such cases we are called improper fractions. So here you have to we have to divide numerator by denominator and go ahead. So I'll show you an example. With that you will be able to solve this problem. So the remaining thing is the same. Once you convert this improper fractions into proper fractions, the rest of the method is same. So 1 or 2 problems is sufficient. We'll do this. So I'll take a problem here, that is y equals x square by 2x plus 1 into 2x plus 3. So dear students, just note here. So if you multiply this 2x plus 1 into 2x plus 3, the denominator will have a degree 2. The power of x will be 2, that is 2x square, 4x square. So forget about the numerical value. What will be the degree of x? It will be 2. So numerator also will have x square and denominator also will have x square. So it means to say it is an improper fraction. So let me not make a note of that. So what I will do is, first I will bring it to a form where we can find a easy method to solve this problem. So what I will do, now since the denominator and the numerator are equal, So I have to adopt a division method. So as it is, I can't divide this. So what I'll do, I'll first multiply this and later on I'll divide. So let us just watch me doing it, and you can follow the steps carefully. So first what I'll do, I'll multiply this, that is 2x plus 1 into 2x plus 3. So what happens here? This will be 2x plus 4x square. So this will be, if you multiply this, this will be 6x t to the plus 3. So what I'll do, I'll rearrange this properly. So I'll take the first order, that is, which is equals to what? X square plus 2x plus 6x is 8x plus 3. So can I write this equals to, this can be written as x square by 4x square plus 8x plus 3. Done. So now if you compare the degree of numerator and denominator, so the degree is same, hence they are, hence again it is an improper, it's an improper fraction. So I'll rub this. Now what I do, now I'll divide the numerator by denominator. What I'll do, so I should have done it here, but anyway, it's important, this problem I'll do it. Okay, let me do it here so that I can use that step. So what I'll do, x square I'll take, I'll take this 4x plus 8x plus 3. So what I do, now straight away it is not possible, I will divide and multiply this by 4. What happens then, because I will have to get 4 here so that I can easily divide this. So what I will do, now x square by 4x square plus 8x plus 3, what I will do, divide and multiply by 4. So what happens to this? This becomes in the numerator 4x square, done. I will write this 1 by 4, I will write separately with 4 because I want to retain this, by 4x square plus 8x plus 3, done. So what, this is equals to what? This is our y equals to, I will take this 1 by 4 outside, I will take, this is 4x square by 4x square plus 8x plus 3. Done. So divide and multiply, I have done this. So now I can easily divide the numerator by denominator. So I had just wrote this to show you it is not possible to divide like this. So I'll bring you to a form where it is divisible. So I'll rub this. Now what I'll do, I'll take 4x square, I'll take this 4x square plus 8x plus 3, done. So I'll divide this, this is divided, once it will be divided. So what happens is 1 into multiply this becomes 4x square plus 8x plus 3. What I have done, I am dividing this, it goes one time. So 1 into this, you get this. So what happens here, I will add. So once you add, So this is plus, so minus, minus, minus. So what happens here? This and this cancels. You are left with what? Minus 8x minus 8x minus 3. Done? So please make a note of this. I'll rub this. This is nothing but 1 by 4. I'll take this 1 plus minus 8x minus 3 divided by 4x square plus 8x plus 3. Done. I rub this. So make a note. So what happens to y? Y becomes finally using this division method. Now look at this. So don't you think? Look at degree of x now in the numerator. It is degree is 1 and now it is what? 2, degree 2. So now it is a proper fraction. Right? So what I'll do? I'll multiply this. I'll rub this. So I'll rub this step. Now after this I will multiply this. What happens? This becomes 1 by 4. So plus into minus, minus 1 by 4. This will be 8x plus 3 by 4x square plus 8x plus 3. So what has happened? This 1 by 4, this 1 by 4 is here. I multiplied this, so this minus into plus, minus. So you multiply this minus into plus, minus 8x, again minus into plus, minus 3. So this 1 by 4 is pertaining to this, so 1 by 4. So what happens? This 8x plus 3 divided by, I'll write this slightly, this is 4x square plus 8x plus 3. Now it looks neat. Now this is our y, isn't it? This is nothing but y. Note. I call this as equation 1. From equation 1, it is noted, it can be noted the algebraic involved is a proper fraction. So equation, it can be noted that the algebraic function involved is a proper fraction. So now let us differentiate this nth time. What happens here? So by differentiating nth times, what happens? Yn. Differentiation of a constant is 0 minus 1 by 4 d to the power of n. So I take this 8x plus 3 divided by 4x square plus 8x plus 3. Done. Now we have come to a stage like before. So now we have to differentiate this. So what we'll do, straight away it is not possible to differentiate this. We shall factorize this denominator and bring it to this form. Done. So what I'll do, so I call this as equation 2. I rub this. So what I call this, let 8x plus 3 by, so I'll factorize this. So 4x square plus 8x plus 3, isn't it? So we have done this. So this becomes what? 2x plus 1 into 2x plus 3. Same thing we have done earlier. So what I'll do, instead of writing this, I'll write this will be 2x plus 1, 2x plus 1 into 2x plus 3 equals to a by 2x plus 1 plus b by 2x plus 3. The remaining thing, same thing what we have done earlier. So but anyway, you need to know the procedure. So we'll let this 1 by 4 is there, we'll think about it at a later stage. I'll rub this too. What I'll do, I call this as equation 3. Multiply equation 3 by 2x plus 1 into 2x plus 3 on both sides. We get. So if you multiply equation 3 by 2x plus 1 and 2x plus 3, on the left hand side what you get? That is nothing but we get 8x plus 3 equals to. So again, just as a reference I am writing this. This is 2x plus 1 into 2x plus 3. So 2x plus 1 cancels, you are left with 2x plus 3. So this becomes a into 2x plus 3 plus b into 2x plus 3, 2x plus 3 cancels, you are left with 2x plus 1. So 2x plus 1. Okay. Now what I'll do, I'll set 2x plus 1 equals to 0 and 2x plus 3 equals to 0, so that I'll get the values of x in both the cases. So what I'll do, I'll write here set set 2x plus 1 equals to 0 or x equals to what? X equals to minus half. What happens here? I'll show you. This is 2x. When you send this to the new right hand side, it becomes minus 1, and x equals to minus 1 by 2. So therefore x will be minus half. Done. So I'll write here first case x equals to minus half. Now I set 2x plus 3 equals to 0. Second case, set 2x plus 3 equals to 0. Therefore x will be, when 3 goes from left hand side to right hand side, it becomes minus 3, and this 2 it goes to the numerator. So this becomes minus, another value for x is x equals to minus 3 by 2. Now if I substitute in this equation, first case, put x equals to minus half, we'll get a value of a or b. If I put x equals minus 3 by 2, we may get the value of b or a. So the main idea is to see that we have to find the value of a and b. For that, all this exercise I am doing it, okay, which we have done earlier. So I'll rub this. So we got the values of this. I call this as equation first case, case 1, put x equals to minus half in equation 4. Then what happens? So here 8 into minus half plus 3 on the left hand side, done, and here a into 2 into minus half plus 3 plus b into 2 into minus half plus 1. What happens here? So 2 ones are 2 fours are 4 into minus 4, that minus 1 into 4, this is 4 into minus 4 plus 3, so you'll have minus 4 plus 3, so minus 1. So what I'll do? I'll rub this. So on the left hand side it is minus 4 plus 3 equals, on right hand side, a into 2 cancels, here minus 1 plus 3 plus b into this 2 cancels, minus 1 plus 1 is 0, so this becomes 0, the entire thing becomes 0. So this is minus 1 equals to what? A2. therefore A equals minus half. Done. I'll rub this also. So A equals minus half. Now I'll rub this. Yes, no use. Now I'll rub this too. Put second case 2. Put x equals minus 3 by 2. Minus 3 by 2 in equation 4. What happens here? That is, on the left hand side, 8 into minus 3 by 2 plus 3, this is on left hand side, equals to A into 2 into minus 3 by 2 plus 3 plus B into 2 into A equals minus half. So 2 into minus 3 by 2 plus 1. Correct. So what happens here? 2 ones are 2 fours are. 4 into 3 is minus 12 plus 3. Correct. If you multiply this goes 4 times. 4 into plus 4 into minus 3. Minus 12 plus 3. Done. Here. This 2 and this 2 cancels. So I left with 3. 1 into 3 is 3. Minus 3 plus 3 is 0. So this is 0. So the entire thing becomes 0. So this is 0 plus. Here 2 cancels, 2 cancels. So minus 3 plus 1. So minus 2. This is B into minus 2. That is B into minus 2. So this is nothing but what? Minus 12 plus 3. That becomes minus 9 equals to minus 2b. Both sides we have minus. Either multiply by minus on both sides or divide by minus sign on both sides. You get or 9 equals to 2b, because I am dividing or multiplying, this both the signs will change. So it becomes 9 equals to 2b. Therefore b equals 9 by 2. So value of b is equals 9 by 2. I'll rub this. I'll rub all this, not required. If you remember, let 8x plus 3 by 2x plus 1 into 2x plus 3 equals to a by 2x plus 1 plus b by 2x plus 3. So before rubbing in the beginning stage I had written this. So later on you have followed some steps. I had rubbed it off. So I am trying to get you back to this position. So what I have done this. So yn equals to 0 minus 1 by 4, done. So I had written 1 by 4 dn of, I'll write this, dn of a by 2x plus 1 plus b by 2x plus 3, right. We had stopped at this and later on we are removed. Now what I will do, we have got the values of a and b, we will substitute the values of a and b. Therefore yn equals to minus 1 by 4. So I put this bracket, dn of, what is the value of a? Value of a was minus half by 2x plus 1, let's say minus, plus b was 9 by 2, 2x plus 3. So if you remember, I have once again I have brought all these things to initial stage what I have done. Now we have to differentiate it, find the antiderivative. So what I will do, I will rearrange this properly, that is yn equals to minus 1 by 4, this will be dn of minus 1 by 2 into 2x plus 1 plus 9 by 2 into 2x plus 3. This is dn of plus dn of 9 by 2 into 2x plus 3 . This d I will write properly. I rub all this now, it is not required. That is, therefore, yn equals to minus 1 by 4 dn of, so this half I will take it outside, this half I have taken, so you will have this minus 1 here, so this will be minus 1 by 2x plus 1 plus 9 into 1 by, I will take right like this, 9 by, this will be this 9, I will take it outside, this will be 2x plus 3, close the lower bracket and close the square bracket, done. So what happens here, this half is common for both, I will multiply this, so what happens here, if I multiply this on the left hand side becomes minus 1 by 8, So now let's differentiate. So what happens here? So I'll take this first because since I want to avoid this minus sign, I'll take 9 by 2x plus 3 minus 1 by 2x plus 1. Can I write like this? This again I write this dn should be here only because so this is equals to minus 1 by 8 dn of 9 by, what I have done, I have brought this plus sign to begin with, so plus 9 by 2x plus 3, this minus sign minus 1 by 2x plus 1. So this is our yn. Now we know the standard formula. So this is equals to what? This is nothing but, I'll rub this because this is of no use. Therefore, yn equals to minus 1 by 8. I'll put this. So now 9, don't write 9 to the power of n, so 9, take it, this is minus 1 to the power of n, so a to the power of n, so here the coefficient of x is 2, so this becomes 2 to the power of n into n factorial divided by 2x plus 3 to the power of n plus 1 minus, so this is minus 1 to the power of n, coefficient of x is 2, this will be 2 to the power of n into n factorial divided by 2x plus 3, 2x plus 1, sorry, 2x plus 1 to the power of n plus 1. So I have removed this divided to the power of n and I have already found the antiderivative, because once you remove this, it means you have to differentiate this for the nth time. So we have done this previously, same thing. Now if you observe keenly, what is common here? We have 1 to the power of minus 1 to the power of n, that is common, 2 to the power of n is common, n factor is common. So I rub this. So this can be written what? We have a common minus 1 to the power of n, here also minus 1 to the power of n, 2 to the power of n, 2 to the power of n, n factorial, all these are common. So now you observe here, therefore yn equals to minus 1 by 8, so 1 by 8, so common, that is minus 1 to the power of n plus 1, minus 1 to the power of n plus 1 into n factorial 2 to the power of n, I'll write this, into, this becomes so this is 9 by 2x plus 3 to the power of n plus 1, minus sign, minus 1 by 2x plus 1 to the power of n plus 1. This is your final answer. So dear students, I repeat, this minus 1 by 8 as it is, minus 1, here also you have minus 1 to the power of n, that becomes minus 1 to the power of n plus 1, n factorial and 2 is common 2 factorial. So we have 9 by 2x plus 3 to the power of n plus 1 minus sign. So nothing is there in the numerator. So you can 1 by 2x plus 1 to the power of n plus 1. This is your final answer. So dear students, it's a very simple problem. Only thing you need to understand the steps and try to recall it whenever it is required. So what you have to do is do this problem once again in a cool mind with lot of concentration, and once you get it, it's easy to solve because we have done this problem. We have to convert this improper fraction to proper fraction by dividing, and later on the same step what we have used earlier. Once you have come to a proper fraction, remaining steps are similar to our previous problem. So in the event in the examination, if you get to solve proper fractions, the method is what I taught you in the previous class, and if you are asked to do improper fractions, you have to divide the numerator by denominator and you have to follow these steps. So we'll take one more problem and we'll wind up to find the antiderivative of arithmetic functions by the method of partial fractions. Okay, so we'll take one more problem. Let us work out this problem in the same pattern what we already did in the previous problem. So here we have x to the power of 4 divided by x plus 1 into x plus 2. So if you factorize this, so the degree of this will be x square. So since the degree of numerator is higher than degree of denominator, it is an improper fraction. So this is an improper fraction since the degree of denominator is less than the numerator. What happens here? See, if you have x plus 1 into x plus 2, what happens if you multiply? This becomes x square plus x. So this will be 2x plus 2. So what happens? This is x square plus 3x plus 2. So what happens? So you can write this y equals to what? X square by x to the power of 4 by x square plus 3x plus 2. Note here students, the degree of x is 2, that is x square is the highest, it is a quadratic equation, isn't it? So, but the degree of x here is 4. Since 4 is greater than 2, it is an improper fraction. So now what you have to do? We have to convert this improper fraction into proper fraction by dividing the numerator by denominator. So let's go. Let's do this. I rub this to what I'll do, I'll take x to the power of 4 and I take this x square plus 3x plus 2. So this is x square, that is x to the power of 4 by x square. It goes 2 times, that is x square times. So if you multiply this, what happens here? This becomes x to the power of 4 plus this becomes 3x cube plus 2x square. I am multiplying this with each term. So this becomes x to the power of 4 plus 3x cube plus 2x square. So what I'll do? This is plus, I'll subtract what happens? Sign changes. So this cancels. You are left with what? Minus 3 x cube minus 2x square. 3x. So this is 3 into x square minus 3, multiply this, minus 3x cube minus into plus minus 3 3s are 9, this is 9 x square plus minus into this becomes minus 6x. Now I add. So what happens here? This cancels, and here also add, and this add. So what happens is 7x square plus 6x. This is 7x square plus 6x. So now if you multiply this, it becomes 7x square plus 7 into 3, 21x plus 2 7s are 14. Now, so we have plus here, plus minus minus minus. So what happens here? This cancels. We have minus 15x minus 14. Now you are left with 7. I'll take plus 7. 7 into x square is 7x square plus 7 to the 21x plus 14. Y equals to x square minus 3x plus 7 plus, I take this, minus 15x minus 14 divided by x square plus 3x plus 2. So the entire thing after division we get this value. It is similar to what is that? QRD. See, quotient. Quotient is what? X square minus 3x plus 7. This is quotient. Remainder. This is remainder. I'll write here. This is your remainder. This is our quotient and this is our divisor. So I use this formula QRD. This is nothing but QRD. Now it is easy to solve this. Now what I'll do, we'll say now, for example, this is y. Supposing I differentiate this once, what happens? So now for example, we'll take d equals x square minus 3x plus 7, isn't it? What happens to d1? d1 will be 2x minus 3. You are differentiating it. So this is nothing but for this you are differentiating separately. So once you differentiate, you get 2x minus 3. Again I will differentiate. 2, what happens here? You will get only 2. This x will go, the differentiation constant is 0, we will get 2. If you differentiate again, d3 will be 0. So therefore, differentiation of this, differentiation of this will be 0. Okay, I wanted to prove that. That's the reason I have shown you this. So what happens yn now? Therefore, differentiation of x square minus 3x plus 7 equals to 0 when n is greater than 2. Because the value of n is 2. Now I will catch hold of this, I will call this as equation 1. I call this as equation 1. Now equation 1 becomes what? Becomes, I'll rub this, becomes yn will be d to the power of n, so x square minus 3x plus 7. So minus into plus minus. So again what I'll do, instead I'll write like this, minus dn of 15x plus 14 by x square plus 3x plus, can I write like this? You multiply this, minus into plus, it becomes minus into plus minus 14. So remaining is as it is. So I have proved differentiation of this is 0 already. So what happens here? I'll rub this now one step. Yes. Yes sir, please abate. Who is asking you not to do so? So therefore yn will be what? So this will be 0 because of what? Because of this factor, minus dn of 15x plus 14 by x square plus 3x plus 2, that is yn equals to, I'll write minus d to the power of n into 15x plus 14 divided by x square plus 3x plus 2. Now I have to find the differential nth derivative of this using partial fractions. So I'll go for this. Let 15 plus 14 by, I'll use this. This is nothing but x plus 1 into x plus 2 equals to a by x plus 1 plus b by x plus 2. I call this as equation 1. I'll rub this. So remember we have a minus value here, minus dn. So don't forget that. So what I'll do, I'll multiply equation 1 by x plus 1 into x plus 2 on both sides. What happens to the left hand side? By multiplying equation 1 on both sides by x plus 1 into x plus 2. We get, I'll rub all this. We get what? So if you multiply x plus 1 into x plus 1 left hand side, both this cancels. So what we left with? This becomes 15x, sorry here, 15x. This is 15x plus 14. So equation 1. So what I'll do, multiply equation 1 by x plus 1 into x plus 2. So what happens on the left hand side? So this gets cancelled, we get 15x plus 14 equals to a into x plus 1 gets cancelled, we will have x plus 2 plus b into x plus 1. I call this as equation 2. Now I have to find the values of a and b. So what I'll do, I'll set this denominators x plus 1 equals to 0, x plus 2 equals to 0. So to find values of a and b, set x plus 1 equals to 0 and x plus 2 equals to 0, isn't it? So what happens here? So first case, x plus 1 equals to 0, therefore x equals to minus 1, correct? And x plus 2 equals to 0, therefore x equals to minus 2. So I am going to substitute the values of 1 by 1 in equation 1. I will rub this. Now equation 1, when x equals to minus 1, equation 2 becomes what? Becomes what? Equation 2, that is 15 into minus 1 plus 14 equals to a into, this is minus 1 plus 2 plus b into minus 1 plus 1. So minus 1 plus 1, it becomes this 0. So what happens here? Minus 14, that is minus 15 plus 14 equals to 1a, that is minus 1 equals to 1a, therefore a equals to 1. So the value of a equals 1, minus 1, the value of a equals minus 1, because minus 1 by 1 is minus 1. Now next case, I will put x equals to minus 2. So I will rub this. Put x equals to minus 2 in equation 2. What happens here? 15 into minus 2 plus 14 equals to a into minus 2 plus 2 plus b into minus 2 plus 1. So this is 30. 15 into 2 is minus 30. Minus 30 plus 14 equals to, this part becomes 0. this part becomes 0, so we'll have minus b, minus 1b, minus 2 plus 1 is minus 1b. I'll write this b properly because tomorrow you should not get confused. B. Now both sides we have minus, so what happens here? This is nothing but minus 16 equals to minus 1b. Multiply both sides by minus or divide both sides by minus, so b equals to 16. B equals to, I'll rub this, what was this? Is nothing but now x by 4 by x plus 1 into x plus 2. That was nothing but what? A by x plus 1 plus b by x plus 2, correct? You multiplied this by x plus 1 plus b is 16 by x plus 2, right? I'll rub this. No, I don't want this minus sign to begin with. I'll rearrange this by rearranging. Y equals, that is 16 by x plus 2 minus 1 by x plus 1. This is our y. So, and y will be what? That is dn differentiation of 16 by x plus 2 minus 1 by x plus 1. Done. Now we will find the answer. So dear students, don't take this as 16 as to the power of n. There is not a. A is the coefficient of x is 1. Here also coefficient of x is 1. That is our a. So therefore, yn will be what? 16 into minus 1 to the power of n into coefficient of x is 1, that is the power of n, and n factorial divided by x plus 2 to the power of n plus 1 minus 1 to the power of n into coefficient of x is 1, so that is our a, 1 to the power of n into n factorial divided by x plus 1 to the power of n plus 1. You remember our d was, I told you, minus 0 minus, it was 0 minus, so that minus sign we had forgotten, put that is equals to minus sign. So what happens here? So this becomes minus 16. So I'll rewrite this. See, if you go wrong once, so if you remember in the beginning, I had omitted this minus when we differentiated minus dn. So take that minus. So what happens here? So I'll interchange now. I'll take this as, so this becomes what? That is yn, that is yn will be minus into this, minus 16 into minus 1 to the power of n into 1 to the power of n factorial divided by x plus 2 n plus 1 so minus into minus becomes plus minus 1 to the power of n 1 to the power of n factorial divided by x plus 1 to the power of n plus 1. So what I'll do? Now again I'll interchange this because I don't want this minus sign to begin it. I'll take this, that is nothing but yn will be what? I'll take first minus 1 to the power of n into 1 to the power of n into n factorial divided by, take this first, that is n plus 1 to the power of n plus 1 minus 16 into minus 1 to the power of n 1 to the power of n factorial divided by x plus 2 to the power of n plus 1. Now dear students, what is common here? I'll rub this. What is common? n and 1 is common. We have got therefore yn will be what? I'll take this minus 1 to the power of n into n factorial so we have 1 by x plus 2, this is x plus 1, sorry, this is x plus 1 to the power of n plus 1, make this as x plus 1, by mistake I wrote n plus 1, so x plus 1 minus 16 by x plus 2 to the power of n plus 1. This is a final answer. So where n is greater than 2, this is your answer. So dear students, I have done some 3 to 4 problems on proper fractions and 2 problems on improper fractions. I think there's more than enough on arithmetic functions, that is to find n derivative of arithmetic functions by the method of partial fractions. So whatever problems you do will be on the same basis, same procedure. I put a fan. It will be on the same basis and same procedure. So let us not waste much time on this. So I stop it at this stage and I'll think about doing what next. So most likely I'll be taking Leibniz theorem after this because I want to maintain that continuity, because after this I'm going in phase, I'm following the procedure so that there should be a chain and it should be easy for you to follow it. So I started with simple differentiation and I've come to antiderivative. The next is we'll go for Leibniz theorem, and after that either partial differentiation or successive differentiation. We'll try to finish up differentiation. So along with this, so I am planning to take trigonometry or vector algebra or infinite series, whatever it is. I'll see what is common for PUC, diploma holders and BE students. So I want to see that everybody are benefited out of my video, that is out of my class. That's the reason I am seeing what is common for both, for all the three, and I am doing it. So either it may take matrices, I'll see what is conducive for you and I'll do it. So with this, I'll stop at this with the note. We'll meet very soon. Please like, share and subscribe to my channel, because that is important. I want your cooperation and your help to promote my video. So help me for this. So dear students, I'll stop here. So God bless you. Take care and try to work out these problems once again. So don't leave it as it is. Don't copy it and just close the books and keep as it is, because you will tend to forget. So mathematics is one subject which need to revise it again and again, otherwise you will forget. So once you get that maturity, then you can take chances, not now. So dear students, I'll stop here. So we'll meet again in the next chapter. So until then, good night, take care, God bless you, good night.